Hello, I'm Seema from Alobasics. I welcome you all for the next video on wave optics. In this video, we have to discuss concept of interference. Means we'll see what is interference, how it occurs, and what happens when interference occurs. Interference is the phenomena which is applicable to all sort of waves, and it was the first phenomena which supported wave nature of light. Now, what is interference? To understand interference, first of all, we should know superposition of waves. All of you have studied earlier waves, so you are familiar with it. And in superposition of waves, we say that whenever we have two similar waves propagate in medium simultaneously, then at any point the resultant displacement is equal to vector sum of displacement produced by individual waves. Means here we are considering two or more than two waves, and when these waves are traveling simultaneously, at that time their resultant displacement at any instant is given by this formula, where we say that y is resultant displacement, y1 and y2 are the individual displacements of the waves which are superposing with each other. As displacement is a vector quantity, while talking about their addition, we should consider their vector sum, where y is this vector quantity, y1 and y2 are also vector quantities. So here we are taking care of their directions also with magnitude. And this superposition of waves is base for interference. We'll understand this more elaborately with the help of diagram after defining interference. Let us define interference. Here I am writing interference of light because we are studying it for light. But interference phenomena is same for sound waves, light waves as well as water waves. Now in interference we consider when two light waves of similar frequency having a zero or constant phase difference propagate in medium simultaneously in the same direction, then due to their superposition, maximum intensity is obtained at few points and minimum intensity at other few points. Let us understand this first of all. What is important here? We have two waves. What sort of waves these are? Their frequency should be same. As well as one more thing is important here, that is their phase difference, and that phase difference should be zero or constant. And these are propagating simultaneously in same direction. That is one more important term. So which are keywords here? Similar frequency, zero or constant phase difference, and same direction. These we can consider as keywords for this. And next keyword is superposition of these. While they are superposing with each other, we have seen in superposition of waves, at any point their resultant displacement is vector addition of the displacement of individual wave. Or here this displacement is nothing but the intensity of that individual wave, or we say that, as we know that intensity is proportional to square of amplitude, we can talk in terms of intensity also, and the maximum intensity and minimum intensity is observed in that case. On that basis, now we define interference, that is The phenomena of redistribution of energy due to superposition of waves is called interference. What is it? This redistribution of energy, maximum minimum energy distribution, due to what? This energy distribution is due to superposition of waves, and that is known as interference of waves, or specifically here I'll say interference of light waves. To understand this interference, we'll discuss it with the help of waves. Let us see a wave. It is the first wave, which is in the red color with amplitude E1. Now, I'm taking another wave which is in blue color, which has amplitude E2. Now, both these waves are traveling in the same direction, that is from left to right, and while they are traveling, they are interfering with each other, or I say that they are coming together with each other at different points. If we observe these waves or displacement for these waves, then their displacement or their resultant displacement is given by this green colored wave. Now what you can see, for red wave as well as for blue wave, both are at the same time, both are on the positive side, both are on the negative side. So at each point, their amplitudes are getting added. At this point, at this point, at this point, everywhere you can see that their amplitudes are getting added. So the resultant of the green colored wave or resultant wave is always E1 plus E2 in this situation. And here you can see that both these waves, they are having same frequency. They are having same phase difference, that is their phase difference here it is 0. And they are traveling with constant phase in same direction and with the same frequency. So we say that these two waves are interfering with each other to give maximum intensity. Here both are getting added with each other. This is known as constructive interference, where E is equal to E1 plus E2. Description of this diagram is given here, which already I told you. Now we'll go for another diagram. Here this is the reference line. Already we saw it in earlier also. And I'm taking first wave with amplitude E1 in red color, second wave with amplitude E2 in blue color. Both are having different amplitudes, but their frequency is same. They are traveling in the same direction and they have constant phase difference. Here I'm not saying phase difference is 0, because now they are having some phase difference. How much is that? All these things we discuss afterward, but phase difference is constant. And for these two waves, now I want to draw a resultant wave, and this resultant wave is in green color. You can see that it is in between these two. Why? Because now resultant for this is E1 minus E2. Now why this resultant is minus here and plus here? Because here they are having 0 phase difference. Whereas in this case, if I consider this particular position, then E1 is positive and E2 is negative. For this position also, E1 is positive, E2 is negative. And at this, E1 is now negative and E2 is positive. And due to that, resultant is in negative side. Whereas at this position, as E1 is greater than E2, we can say that E1 minus E2 is positive and here E1 minus E2 is negative. And for this resultant wave, we are having resultant displacement is E1 minus E2, that is known as destructive interference. So with the help of this diagram, you can more clearly understand how we get maximum intensity and minimum intensity in case of superposition of waves, or how we can get maxima and minima. We are familiar that light is in the form of transverse waves. So we apply for transverse wave only, and then we know that this is representing crest and this is representing trough, or we call it as crest and trough. When crest of one wave is coinciding with the crest of another wave, or trough of one wave coinciding with trough of another wave, then displacement is larger, and as displacement is larger, we call it as constructive interference. Whereas when crest of one wave is coinciding with trough of another wave, or crest of second wave with the trough of first wave, in that case, the resultant will be giving minimum intensity, and that is said to be destructive interference. So here you can understand when we get larger displacement and less displacement, and it depends on how these waves are arriving, by how much phase difference is present between them, that will decide whether we have constructive interference or destructive interference. And here, due to that, we are getting redistribution of energy, that is maximum and minimum. For constructive interference, E is equal to E1 plus E2. If this red and blue waves are having same amplitude, in that case, resultant E will be twice of the amplitude, or it will be the maximum amplitude. And if their amplitudes are same, then for destructive interference, resultant E will be 0, because E1 will cancel out E2. So if amplitude of two waves are same, in that case, for constructive interference or for maximum intensity, we'll get maximum value, that is twice of the intensity of each, whereas for destructive one, we get it as 0. Now this interference we apply for water waves. How it looks for water waves, that we'll see. And for water waves, I'm considering these are the two sources of water waves, or these are the 2 points in water where simultaneously we are dropping water droplets, or we are dropping some objects. But here it is very important that we are dropping it simultaneously. And in that case, you get such type of wavefronts. Now, these waves which you observe here, they are shown in 2 different colors, because blue color is representing crest of the wave and orange color is representing trough of the wave. Now, as I told you here, when crest of first wave coincide with the crest of another wave, there is constructive interference, and when crest of one wave coincide with trough of another wave, there is destructive interference. At constructive interference, we know that intensity becomes maximum, so we call it as bright band. And for destructive interference, intensity becomes minimum, so we call it as dark band. When we see two crest of one wave, it's coinciding with the trough of one wave, means blue color coinciding with orange color, then those points will be dark points. And when blue color is coinciding with blue color, we get the points which are green in color. Now, only blue color is coinciding with blue color? No, with that orange color is coinciding with orange color, that is trough, it's coinciding with trough. Blue color is coinciding with blue color, means crest is coinciding with crest, that is representing constructive interference, and which is shown here by these green points. If I join these green points, I get such type of band which represents the bright color or bright band. Combination of crest with trough or trough with crest. In that case, their combination is considered to be bright points. And all these bright points gives us, dark points give us dark band. And here you can see these dark bands here. Here you can observe that bright band, then dark band, bright band, then dark band, and then bright band. Now bright and dark I'm considering as a symbol for constructive interference and destructive interference, or in other way for the maximum intensity and for the minimum intensity. So water waves can be observed in this way, and similar type of interference pattern can be observed for light also. We have seen interference of water waves and how interference is there. We'll see it again with the help of diagram so that you can keep it more in your mind very easily on the point basis. First diagram, in which these are the two sources, these are the waves coming from this. When they are coming together, at that time they are in phase, and due to that we say that here there is a bright point or constructive interference occurs at point O when waves are combining. Now for the second point, I'm not going for the central position, but some another position I'm going here. And at this point also I can see that now both waves, as I have seen here, are coming to this point at the same phase of vibration or in the same phase. Similarly, here also they are coming in the same phase, but the distance traveled by the first wave and by the second wave is different. So here their phase is 0, but here phase is not 0, but they have some constant phase difference, and due to that here condition is applied, that is phase difference is constant, but the state of vibration for both the waves is same. So again point is bright. And in next diagram you can see these waves are coming here, and how these waves are coming, crest of one is falling with the trough of the other wave, and due to that here there will be minimum intensity. So the point will be dark, and we call it as destructive interference. Here constructive interference, here also constructive interference, and here there is destructive interference. Or to keep in mind these things, we say that the interference taking place at a point of maximum intensity is called constructive interference. And for that, what is condition? Crest plus crest or trough plus trough. And for interference taking place at a point of minimum intensity is destructive interference, where crest of one is matching with trough of other, or trough of one is matching with crest of another one. So in this way, very easily you can keep in mind when should be the constructive interference and when should be the destructive interference. Here I'm giving you questions on today's topic. These are descriptive type of questions. If you solve these questions properly, it will help you for your board exam. Thank you for watching. See you soon in next video.